Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve one of the hardest Math Olympiad problems. Alright, so we have 3 to the power of x is equal to 7 to the power of x plus 2. Now, I actually have two methods of solving this problem. So let's first start with method 1. And so we have 3 to the power of x is equal to 7 to the power of x plus 2. And an important property of exponents is that if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So the exponent essentially distributes with the base. So right here we have 7 to the power of x plus 2, and this is going to equal 7 to the power of x times 7 to the power of 2. So now I have 3 to the power of x is equal to 7 to the power of x times 7 squared. Now I can divide both sides by 7 to the power of x. So now I have 3 to the power of x over 7 to the power of x is equal to, these two cancel out, so simply 7 squared. 7 squared now is equal to 49. So I have 3 to the power of x over 7 to the power of x is equal to 49. Now, if I have something in the form a to the power of m over b to the power of m, this is actually equal to a over b to the power of m. So right here, 3 to the power of x over 7 to the power of x, this is going to equal 3 over 7 to the power of x. So now I have 3 over 7 to the power of x is equal to 49. Now I can take the log on both sides. So now I have log of 3 over 7 to the power of x is equal to log 49. Now, an important property of logarithms is that if I have something in the form log a to the power of b, this is equal to, I can actually move this exponent b to the front of the logarithm. So this would be equal to b times log a. So for log 3 over 7 to the power of x, I can move this exponent x to the front of the logarithm. So this would be equal to x times log 3 over 7. So now I have x times log 3 over 7 is equal to log 49. So now I can divide both sides by log 3 over 7. So then these two cancel out, and I would be left with x is equal to log 49 over log 3 over 7, which is the same thing as log base 3 over 7 of 49. Now, my second method to solve this problem is, well, our initial problem was 3 to the power of x is equal to 7 to the power of x plus 2. So I'm going to first take the log on both sides. So now I have log 3 to the power of x is equal to log of 7 to the power of x plus 2. And remember, an important property of logarithms is that if I have something in the form log a to the power of b, I can move this exponent b to the front of the logarithm. So this would be equal to b times log a. So for log 3 to the power of x here, I can move this exponent x to the front. So I have x times log 3 is equal to, same goes with 7 to the power of x plus 2. I can move this exponent to the front. So I have x plus 2 times log 7. Now, I can actually distribute this log 7 and multiply this. So I have x plus 2 times log 7. So if I distribute our log 7 here, I have x times log 3 is equal to log 7 times x, so x times log 7 plus 2 times log 7, so 2 log 7. Now I can go ahead and subtract x times log 7 on both sides. So now I have x times log 3 minus x times log 7 is equal to 2 times log 7. Now, from these two terms, I can simply factor out x, because both of these terms have x in them. So now I have x times log 3 divided by x is simply just log 3. And minus x times log 7 over x is simply log 7. And this is still equal to 2 times log 7. And now I have x over here, and we want to isolate x, obviously. So I'm going to divide both sides by log 3 minus log 7. So now these two will cancel out, and I have x is equal to 2 times log 7 over log 3 minus log 7. And now if I have something in the form log a minus log b, this is the same thing as log a over b. So log 3 minus log 7, this would be equal to log 3 over 7. And if I have something in the form a times log b, this is the same thing as log b to the power of a, because remember, we can actually move this exponent to the front. So 2 times log 7, this would equal log 7 squared, which is equal to log 49. So now I have log 49 over log 3 over 7. Alright, so in this problem, I have 8 to the power of x plus 2 to the power of x is equal to 30. So I'm going to first start by rewriting 8 as 2 to the power of 3. So now I have 2 to the power of 3 to the power of x plus 2 to the power of x is equal to 30. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of n to the power of m. So I can switch the places of n and m. So in this case, I have 2 to the power of 3 to the power of x, and I'm going to switch the places of 3 and x. So I get 2 to the power of x to the power of 3 plus 2 to the power of x is equal to 30. Now, I'm going to let the variable u equal 2 to the power of x. So now if I substitute in u for 2 to the power of x, I get u to the power of 3 plus u is equal to 30. And now I can subtract 30 on both sides. So then these two cancel out, and I get u to the power of 3 plus u minus 30 is equal to 0. Now we have an equation here, and we need to find what value of u makes this equation equal to 0. So what I'm going to do to start is rewrite 30 as negative 27 minus 3. And the reason I did this is because 27 is the same thing as 3 to the power of 3. Notice how we use something in the form u to the power of 3 plus u. We could think of u as 3 in this case. So 27 is the same thing as 3 to the power of 3, and we have this minus 3. Now I'm going to put this in the form u to the power of 3 minus 3 to the power of 3 plus u minus 3 is equal to 0. So now, if I put this in parentheses real quick, if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus ab plus b squared. So in this case, this turns into u minus 3 times u squared plus 3u plus 9 plus u minus 3, which is equal to 0. And now, because both of these terms have a common factor of u minus 3, if I factor out u minus 3, I get u minus 3 times u squared plus 3u plus 9 plus 1 is equal to 0. And now from here, 9 plus 1 is 10, so I get u minus 3 times u squared plus 3u plus 10 is equal to 0. Now this gives me two equations. I get u minus 3 is equal to 0, and I get u squared plus 3u plus 10 is equal to 0. So u minus 3 equals 0. That's pretty easy to solve. All I have to do is add 3 on both sides, and I get u is equal to 3. Now remember how we let u equal to 2 to the power of x, meaning 2 to the power of x is equal to 3. And now to solve this, I'm going to start by taking the log on both sides, so I get log 2 to the power of x is equal to log 3. And if I have something in the form log a to the power of b, I can move this exponent b to the front, so it's going to equal b times log a. So in this case, I have log 2 to the power of x, and I can move x to the front, so I get x times log 2 is equal to log 3. And now if I divide both sides by log 2, these two cancel out, and I get x is equal to log 3 over log 2. Now log 3 is equal to 0.4771, and log 2 is equal to 0.301, meaning this is equal to x is equal to 1.539. Now, going back over here, we have u squared plus 3u plus 10 equals 0. And let's use the quadratic formula to solve this. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is 3, and c is 10. So I get u is equal to negative 3 plus or minus the square root of b squared, which is 3 squared, minus 4 times a, which is 1, times c, which is 10, all over 2a, so 2 times 1. And this gets me negative 3 plus or minus the square root of 3 squared, which is 9, minus 4 times 1 times 10, which is 40, all over 2, which is equal to negative 3 plus or minus the square root of negative 31 over 2. Now, the square root of negative 31, that's a negative number, so that doesn't work, meaning my only solution is 1.539.